Good afternoon, I'm Mr. H. Thank you for joining me for this video where we have to find missing angles for the representation we have here before us on an XY axis. Here's my x-axis, my y-axis. This point right here is the origin. The missing angles we have to find are this one right here and that one over there. We see this one right here and that one. I'm telling you that this is my x-axis. This right here is parallel to that, so you have a 90 degrees here. This is parallel to that. Everything else will follow from there. You have A, B, C, D, E, F, which are representing a variety of triangles that you can form. You know you have a triangle ABF, you have a triangle ABE, there's a triangle BFE, there's a triangle B, C, and D. There are technically 4 triangles, but our focus here is on only 3 triangles. We'll talk about everything as the turn or the time comes along. We have a certain axis of rotation here from the x-axis, which you know is your 0 degrees. We have a certain amount of rotation up to this line right here. You know here's my x, here's my y, so there's 90 degrees. Let's look at this triangle ABE. We're looking here at triangle ABE. We can designate it as that, and the triangle looks something like this. Here's your 90 degrees. The origin is right over here. If I'm telling you that you have a certain amount of rotation, that's theta degrees, your 90 degrees, we're calling this angle x. We have to find that angle because it'll help us find the missing angles, these two right over here. How can you do it? You have a total amount of rotation theta less this difference with this 90 degrees, and that exactly is that angle. You can easily find this angle right here, which will correspond to point E over here. You can easily find that. The sum of internal angles are always 180. You have this, you have that, you need to find that. E plus this angle 90 plus this theta minus 90 should all equal 180. These will cancel out. E will equal to 180 minus theta, and that's exactly what it is. This angle right here is 180 minus theta, and let's mark it out. 180 minus theta, and it refers right over there. We don't need this anymore because we've done this. We can keep things clean as we go along. So this part right here is done. Let's focus now on these two because that would be the next step. We have this large triangle BCD. In here you have the smaller corresponding, or let's just say we have smaller similar triangle generating. Here's 90 degrees, here's 90 degrees. We've generated and we've determined this to be 180 minus theta. We have to determine that, we have to determine that, and it's not hard. These are similar triangles, therefore you have corresponding angles. This angle here must be equal to that because you also have a pair of parallel lines cut by a transversal, therefore they're corresponding. This angle must be 180 minus 30, and it will be the case. We have to determine this angle right here, and it wouldn't be hard because you have now 3 angles. The sum of those 3 angles should equal to 180, and let's bring them out over here. We're looking here at the triangle BFE. We have one angle which is missing, we'll call that angle Z. We have one angle right here, 90 degrees. We have another angle, this angle E, we've determined to be 180 minus theta. All of this should equal 180. This cancels out with that. Z is equal to theta minus 90, and that's what it will be. This angle here will be theta minus 90. We've already determined this. This right here is 180 minus theta. So technically the missing angles have been determined, but now let's talk about something fun, because in all of this, the triangles we've generated, they're all similar triangles. Everything we've shown you over here are similar triangles, and everything here will have equal angles, and I'll show that to be the case. Before we do anything, let's look at this small triangle. We're looking here at triangle ABF. ABF. One of these angles is this right here, and let's just draw it out. It looks something like this. You have 90 degrees here, you have a certain angle here, but we have this angle which we determined from the very start to be theta minus 90. This angle must be, you know what, 180 minus theta, and it will be the case. Theta minus 90 plus that 90 plus, we'll call that angle W, should equal 180. We have this and this cancelling out. We'll have W is equal to 180 minus theta, and that's exactly what it is, 180 minus theta. Now let's talk about that fun item that I was talking about. All of these being similar triangles, each of these triangles that we can generate will always have the same angles. Starting here with triangle ABF. Starting with all the angles that you have, let's mention this again. This was right here, theta minus 90, this angle right here. We have a theta minus 90, we have right here a 90 degrees, 180 minus theta. Now let's look at this other triangle ABE. Triangle ABE, which you can easily picture it to be that. That triangle ABE has a theta minus 90. It has this 180 minus theta, and it has this right triangle which is 90. Now let's look at these two triangles. Remember there are 4 in all, but our main focus was just 3, but now we're just going to all 4. Looking at this small triangle BFE. When you look at BFE, you have this angle right over here which is theta minus 90. You have this right triangle which is 90 degrees, and then you have this 180 minus theta. This large triangle BCD is a similar triangle as the small one, and the angles must be all the same. You have this shared angle theta minus 90, you have a 90 degrees, and then you have that corresponding angle 180 minus theta. Look at all these 4 triangles. Every single angle is the same because all of these ended up being similar triangles. And that right there brings us to the end of the exercise. Our main item was just to find this and just to find this, and we started everything by this theta minus 90 by means of that rotation from x-axis. Thank you for watching this video. Have a good day.